Okay, what we're going to do, we're still doing inequalities. We're still solving for x for the inequalities. But right now, the stuff that you did earlier was all linear. It was just straight line stuff. You get one answer, it was no big deal. All right, today, it's a little bit more involved. So if it's not linear, then what's the other kind of equation that we had? Not a linear equation, a what? Yeah, give me a word, come on. With x squared, x constant, what's that? What is it? Yes, quadratic, okay? Quadratic equations, okay? So that's what we're going to do right now. We're going to do a quadratic inequality. It's not an equation, right? Because equation means it's equal. We're going to do a quadratic inequality. So it's a little bit trickier than just doing a regular quadratic equation, all right? You just don't solve for x and boom, there you're done. You got to do a few things, so we'll show you. But the beginning is very much like what you're used to. Less than 0. I think it's just less than, yep. Alright, so here it is. We have to solve for this. It's a quadratic inequality because this stuff is less than 0. We want to find all the values for x that make this thing less than 0. Right. You know how we've been having two answers a lot of times? In fact, most of the time, right? You usually get two answers. Well, you're going to get more than just two answers for inequalities, okay, like this. I'll show you. I'll just show you step by step. I'm not going to try to talk it out too much. Let's just do it. First thing we do. I know it says less than 0, and this is really going to blow your mind. But what we're going to do is we're going to do this. We're going to say we're going to make it equal to 0, and I'll show you why in a second. All right, so just bear with me. All right, once we finish it, you'll look back and hopefully you'll say, oh, okay, now I know why we did that. But if I try to explain why we're going to do that now, it's going to blow your mind. All right, so right now, let's just do this. I know it says less than 0, but let's do this. Let's make it equal to 0 and find out what x is actually equal to. But that's not what our main goal is, right? Our main goal is to find what x is to put into here to make this whole thing what? Less than 0, okay? That's our eventual goal. We'll get to that in a minute. For right now, let's just find out what x would equal, okay, if this thing was equal to 0. Everybody got that? All right, so we could solve for x several different ways. We could use we could complete the square, right? We could use the quadratic formula, okay, or we could see if it factors. Do you think this thing factors? Yeah, it does. Okay, this is pretty easy to see. Sometimes they're a little more complicated to see if they factor or not, but on this one it's pretty easy to see. All right, got an x here and an x here. What do you got? -4, +3. Does that work? Set them both equal to 0, so what's x equal to? 4, and x is also equal to what? -3. All right, let's plug it back in just to see if it works, just for fun. All right, put the 4 in there. 4 squared is 16. 16 minus 4 is what? 12. 12 minus 12 is 0. That works, doesn't it? Okay, let's try -3 in here. -3 squared is 9. Minus -3 is +3. 9 plus 3 is 12. Minus 12 is 0, and it works too, doesn't it? All right, so I just wanted to make sure that that works. What if I put it into this thing, though? What if I put a 4 into this? I'm going to get 0, right? If I put a 4 in for this, I already did it here once, didn't I? So what did I get? I got 0, didn't I? Because this is 16 minus 4 is 12 minus 12 is 0. Is 0 less than 0? No. 0 isn't less than 0, is it? If I put a -3 in for this, what do I get? I get 0. Is 0 less than 0? No, it's not. Okay? So these two don't really work for this, does it? But this is going to help me. These numbers right here are very, very helpful in order to find out what this is. And I'll show you here in a sec. Let's try a different color. I'm going to draw a little number line. Right? We've been doing some number lines with this stuff. So here's a little number line. And do you see what I found for x? I'm going to put those two values on my number line. So I'll put -3 on the left because that's smaller, right? And I'll put 4 over here on the right because that's bigger. You don't have to fill in all the numbers. You can just keep it like that if you want. We good so far? Alright, now watch what we've done. What I've done is I've split this number line into basically 3 different chunks. I've got all the numbers that are less than negative 3, right, going this way. Would you agree? So from here all the way to the left are all the numbers that are less than negative 3. What about here? I also have the numbers that are greater than 4 here. And I also have in between what? All the numbers that are what? What do you think? Well, just use a regular normal word. What? I got this and this, all the numbers what? In between, right? So look, I got all the numbers that are less than negative 3 going this way. I got numbers that are greater than 4, and I got numbers in between here, right? In between negative 3 and 4. So what I'm going to do is this. I'm going to use this. I want to find what x's make this thing right here work. Now I know negative 3 doesn't make that work. Agreed? Because negative 3 makes this 0. 0 is not less than 0. So negative 3 does not work. 4 doesn't work. So if I put a 4 into this, that doesn't work because, again, it would be a 0. 0 is not less than 0. But I do have numbers that are less than negative 3. I do have numbers that are greater than 4. And I do have numbers that are in between. Let's think about this for a second when I say less than 0. When I say less than 0, what kind of a number is less than 0? A negative number, right? So what I want to do, I've got 3 choices. I've got the numbers to the left, the numbers in between, and the numbers to the right. I want to try any of those numbers. Okay, I can pick any number. It doesn't matter as long as it lies within those ranges. And I want to stick it in here and find out which numbers make this thing negative. So do all the numbers to the left of negative 3 make this negative? Do all the numbers to the right of 4 make it negative? Or do all the numbers in between make it negative? Well, the only way to check is to stick a number in, right? Let's try the numbers in between. Give me a nice easy number between negative 3 and 4. What's the easiest number to work with? What's the easiest number? I got negative 2, negative 1. Those are okay numbers, but 0. 0 is the easiest number, isn't it? Wouldn't you agree? All right, you can put a 1 in there, I guess, but I think 0 is the easiest number to put in here. So watch. Listen to this. If I pick any number between negative 3 and 4, and it goes in here, if that number makes this thing work, if it makes it less than 0, then every single number in between here makes it. And I'll show you in a second. You said 0, right? So let's stick a 0, because 0 is in between here somewhere, isn't it? So 0 is about right there. Actually, probably be closer to here, but who cares? It's somewhere in between. Stick a 0 and see what happens. 0 squared is minus 0 is 0. Minus 12 is what? It's negative 12. Is negative 12 less than 0? Is negative 12 negative? Yes. So if 0 makes this thing into a negative, watch what I'm going to do. I'm going to put a negative right there. That little dash is a negative. Okay. If 0 makes this thing negative, then any number between negative 3 and 4 is going to make this thing negative. If you don't believe me, let's try another number. Pick another relatively easy number between negative 3 and 4. Positive 1. Let's put a 1 in there. 1 squared is 1. Minus 1 is, right, that'll be 0. And 0 minus 12 is negative 12, isn't it? Okay, you follow me on that? So a 1 makes that thing negative. Let's try one a little bit crazier. You guys said negative 2 earlier. Let's try negative 2. Right, we tried 1, and it still made it 0. Let's try negative 2 and see if that makes this negative. Put a negative 2 in for this. What's negative 2 squared? It's 4. Let's write this right there. Minus negative 2. What's minus negative? Plus 4. I'm sorry. What are we putting in? We're putting in a 2, aren't we? Yeah, sorry. Plus 2. And then what's that? 6 minus 12 is negative 6, which is still what? Negative. It's still less than 0. It's still a negative number, right? So I could keep going all day if I wanted to. But I could pick any number. I could even put decimals, like negative 2.7, right? Or negative 1.8. Or 1.372. I could pick any number. If I put it in for x, guess what? This thing is always going to become what? Negative. You see that? We'll circle it. So everything in here is going to become negative. So really, that's my solution. My solution is all the numbers between. Well, what about the numbers to the left? What if I picked a number to the left of negative 3? Does that still make it negative? Well, let's see if it does. Tell you what, let's get rid of all this mess. If I can grab them. There we go. Alright, watch this. Let's pick a number to the left of negative 3. Not a real big crazy number, so what would the easiest number probably be? Negative 4. Let's try negative 4 and put it in here. Negative 4 squared is 16. Minus a negative 4 is plus 4. And that's 20 minus 12 is 8. It's positive 8. So all the numbers to the left of negative 3 are going to make this thing what? Positive. Do you see that? So it's not less than, so I can't use any of these numbers. What about all the numbers to the right of 4? Let's try an easy number to the right of 4. Well, try 5, right? Okay. Stick 5 in here. 5 squared is 25. Minus 5, oh, that's 20 as well. 20 minus 12 is 8, and that's greater than. So that's going to make everything here positive. So everything bigger than 4 is going to make it positive. Everything less than negative 3 is going to make it positive. Only the stuff in between the two numbers is going to make this negative. Why do I want to make it negative? Because of this thing right here. Because it says I want to find all the values for x that make this thing what? Less than 0 or negative. You see that? So what's my answer then? My answer is all the numbers between where? Negative 3 and positive 4. How do we write that in this notation, this new notation that we learned? What do they call that? What kind of notation they call that? I forget it, tell you the truth. I'm asking you because I forget what they say. Interval notation, that's what it is. They call it interval. Let's write that down. We'll call it interval notation. No, it's supposed to be an N. Crazy looking. All right. Interval, no, it's an N. All right. I know it looks like an N or a W or something, but I do this all the time. I'll write something crazy and I'll say, okay, this is what it's supposed to be. And Mr. Hamrick, that looks like a W. I'm like, yeah, I know. I told you already. You know, that's so irritating sometimes. All right. Anyway, so interval notation. Everybody got it? So how do I write that in interval notation? What's my answer? It's all the numbers between negative 3 and what? 4. But do I include negative 3? Can negative 3 be included? No, because when I put negative 3 in for this, I got a 0. 0 is not less than 0, so I cannot include negative 3. So it's got to be what? It's got to be parentheses. It's got to be open, right? Because it doesn't include negative 3. What about a positive 4? Can I put positive 4 in there? No, that doesn't work either. So I can't include a positive 4, so I have to make it open, which is a parentheses in this interval notation. All right? This right there is the answer to this problem. So it's not just two answers, is it? It's actually, how many? 4 answers? Is that right? A couple? How many is a lot? Yeah, it's an infinite number of answers. It's every single number between negative 3 and 4. How many numbers are there between negative 3 and 4? There's an infinite number. Right, you have to include the decimals, right? There's an infinite number of numbers between negative 3 and 4. So there's actually an infinite number of answers that can go right there. That doesn't mean, just because there's, this is kind of weird, this will blow your mind. Just because there's an infinite number of answers that will work, does not mean that every single number will work. You're like, well, if there's an infinite number, I thought all the numbers were infinite. Yeah, but in between any 2 points, there's an infinite number of numbers, right? But that still doesn't include all the numbers. Isn't that weird? All right. Gave you something to think about. All right. I'm not going to go on any more than that. Does that make sense? So what do we do first? First thing we do, we kind of forget about the less than or greater than or whatever they tell us. At first we do. What do? We set it equal to. Everybody see that? So we set it equal to 0. These are those two numbers that I put on my number line. Okay? I'll make this a little extra big. So this and this are the two numbers I want to see in the number line. And what do we get? We get numbers to the left, to the right, and in between. Correct? We have to find which of those numbers is going to make this thing right here work. Which one of these is a solution to this inequality? And that's what we do. All right, let's do one more. We kind of get the idea, but we got to do another one, right, to kind of solidify what we've been talking about here. So let's do another. As Zinkoff would say. You guys don't even know Zinkoff, do you? I did tell you about that, though, didn't I? Where's the other problem? Oh, here it is. Watch. We're going to solve. It's another quadratic inequality. So 2x squared plus 5x minus 12. You guys watching? Greater than or equal to 0. Now, I'm not really sure if this thing factors or not. You could take a couple seconds to go through it and see if it does factor. Alright, if you didn't want to, you could use what? Quadratic formula. Okay, now this thing actually does factor, alright, but just for fun, let's do this. What are we going to do first of all, before we do anything else? We're going to set it equal to 0. I wouldn't divide by 2 on this one. So what we're going to do first of all is we're going to set it equal to 0, alright? We want to find those 2 points on our line, right, that kind of separate our number line and, you know, left, right, and in between. We want to find those 2 numbers. That's why we set it equal to 0. Alright, so we could factor it. This actually does factor, but just to practice quadratic formula, let's do that really quick. Okay, negative b plus or minus square root b squared, which is 25, minus 4 times a times c. And that's all over what? 2a. Alright, or actually 2 times 2, which is 4. We'll do that in a sec. Alright, so it's negative 5 plus or minus square root. What do we get here? 96, is that right? Yeah, 8 times 12 in that 96, and it's plus. So 25 plus 96 is what? 125 minus 4. That's 121. Can you do that in your head? Over 4. What do we get? 1, negative 5. What's the square root of 121? It's 11 over 4. Let's see. We got negative 5 plus 11 over 4, which gives you 6 over 4, which is 3 over 2. That's one. I'm not going to circle it, but that's going to be one of my points on my number line. And then you also have negative 5 minus 11 over 4. That's negative 16 over 4, which is negative 4. We good? So those are my 2. I'll put it in a box. I'm not circling it. This is not my answer. Okay, but these are the 2 numbers that I want to put on my number line. Alright, so here's my number line right here. And let's use a different color. Change things up a little bit. Alright, so negative 4, it's going to go right here. 3 halves is the same as, what, 1 1/2, isn't it? So I'm going to put that right here. This is a time where I think it might be a good idea to write it as a mixed number, just so you can kind of see where you're at on the number line. Alright? Now, what do we do now? Well, we pick a number. We pick a number either in between or to the left or to the right and see if it makes this thing work. Now, when I say it makes it work, what does this have to be now? This has to be greater than or equal to 0. So what kind of numbers? Positive or 0, right? So these 2 numbers actually do work this time. We just have to find out, do the numbers in between make it positive, or do the numbers to the outside make it positive? So let's try one. What about in between? What would be a real easy number that lies in between these 2? 0. I always try to pick 0. Okay? Sometimes it lies in between. Sometimes it lies either to the left or to the right. But I would always try to pick 0 because 0 is the easiest number to use. Alright? So let's put a 0 in there. This is 0. That's 0. Would you agree if I stick a 0 in for both of those? So negative 12. Is negative 12 greater than or equal to 0? No, it's not. So it comes out negative. So any number, watch, 0 lies between these 2, right? So any number that lies between here and here is going to give you what kind of a number? A negative number. And I always like to put that little negative sign right there so I know. So any number between here and here is going to be negative. Well, what do you think might be true about the outsides then? The outsides will probably be positive. Now, just because both examples came out where the middle was negative and the outside was positive does not mean that's always going to happen. Sometimes in between will come out positive and to the outside will come out negative. It just all depends on the problem. It just happens that these 2 examples that they gave you in the book, the middle came out negative. Alright? So don't just think this is a pattern. It's really not. Alright? It just happened to be that way. I would. Okay? Just in case, I would. Okay? So let's pick a real easy number after 1 1/2. 2. So let's put a 2 in for this. Now, the math is a little bit more involved than it was before, but let's do it. 2 squared is 4 times 2 is 8. Put a 2 in for that. What's that? That's a 10. And then minus 12. I don't really care what the actual number is. I just care if it's positive or negative. So this is 18 minus 12. That's going to be positive. So that means any number to the outside this way is going to be positive. Agree? And again, just to be sure, let's pick a number to the left. Easiest one would be negative 5, right? So let's put in that. Negative 5 squared is 25 times 2 is 50. Put in a negative 5 for this. That's negative 25, right? And again, I don't really care what the actual number is. I just care if it's positive or negative. Well, that's going to be 25 minus 12. That's going to come out positive. So all the numbers in that direction are positive. So which numbers am I looking for? Am I looking for all the negatives, or am I looking for the positives? I'm looking for the positives. Why? Because this problem right here says I want to find all the numbers that all the numbers for x that I could put in for this to make this thing positive or 0, right? So if I was to graph it, what would I do to graph it? It's a bracket, right? And it's what? All the numbers this way. And it's also what else? A bracket, because you can include 1.5, right? Because it's or equal to. And all the numbers what? To the right. How do I write this in that interval notation? Well, where am I going? I'm going all the way to the left as far as I can. Where is that? It's negative infinity. So I'm going from where? Negative infinity to negative 4. So I go from negative infinity to negative 4. It's always open at infinity because you can never get there. In this case, it's closed at negative 4, isn't it? What about this one? We start at 1.5, right? We're going from left to right. We start at 1.5 or 3/2, and we go where? To positive infinity. Okay? Now, it's always open at infinity, but in this case, what? It's closed at 3/2. What do we put to include both of them? A U for union. Remember that the other day? That's a union. So we say this union this. That union is not that big of a deal, is it? It's just saying both of them. You can say and, but we don't say and. It's actually an or, tell you the truth. It's either numbers this way or this way. Because I can't think of this. You can't say and, because if I pick a number to the left of negative 4, I can't say that and this. Because it... Say that. Right. Like if I said on the other one, I can say and. I don't know. I had that explanation in my head, and it just flew away. And I explained this. It can't be both, right? You can't have a number that's less than negative 4 and also at the same time greater than 1.5. Yeah, that's what it was. Okay? Did you see that? But I can have a number that is greater than negative 3 and less than 4. All right? So this would be an and this would be what? An or. Okay? I could either have a number that's less than negative 4, or I could have a number that's what? Greater than 1.5 or 3/2. All right, that's my answer right there, by the way. That's how I would write it. I'd write it exactly like that. Make sure you use that interval notation. That's really not that hard, is it? It's different than what you're used to, but it's not that hard. Because if it's or equal to, that means you just have a little bracket here. Everybody see that? If it didn't have the or equal, then the only thing different would be what? Yeah, instead of a bracket, it would be what? It would be a parentheses. That's the only thing different. Okay? All right. So that's what we're trying to do. We're trying to find whether this side is greater than, which means it was positive, or if this side is less than, which would make it negative. And that's what we do. We solve for x, right? You get x by itself. Put those two numbers on here, and then you try some. That's all you do. Try some numbers in between, see if it works. Try a number to the left, try a number to the right, see if they work. And just use the numbers that make this thing work. And when I say make the thing work, what am I talking about? I'm talking about make this particular problem positive, right? So this is the number that works, and these are the numbers that work right here. But on this other problem, I'm looking for what? I'm looking for all the numbers that make this thing negative. So I'm only looking for the negatives, which happen to be in between. I'll say this again. Just because these two examples had negative in between these two doesn't mean every problem that you're going to do is going to have negative in between. All right? Sometimes, depends on the problem, sometimes the negatives will be on the outside, sometimes the positive will be in the inside. We good? Okay. Alright, I hope that helps. And let me give you a worksheet and you can work on that tonight.